Get us started. My name's Erin Dolan, and I'd like to welcome everyone to the session of Online with LSE. As a reminder, the whole idea behind this webinar series is to provide a sort of virtual journal club for people in the broader community to see sort of behind the scenes into education studies. And what I'm going to do as we go is encourage you to ask questions. And the way that you're going to do that is you're going to use the Q&A function. So you can see on the screen right now that there's a red box around the Q&A function, and that's the way that you can post questions, and we'll use those questions from the audience to guide discussion. And it's my great pleasure to invite Dr. Stanley Lo to this session of Online with LSE. Stanley, would you be willing to advance to the first slide?
Yes.
Great. So he's an assistant teaching professor at the University of California at San Diego, and he's going to talk about a really interesting paper he published recently in LSE that uses graph theory to examine how students interact in small group learning settings. And to set the stage, he's kindly put together a handful of slides that will give an introduction or a refresher for folks who might not have looked at the paper recently, or for folks who may not have had a chance to read it. And then we'll shift to some Q&A time as we move through the webinar. So Stanley, would you like to go ahead?
Yes, thank you. Thank you, Erin, and also LSE and ASCB for having me here today on the webinar. So it's pretty exciting to be able to share the work that my students and I have done on this graph theory project with you. And the original sort of motivation for developing this methodology is really thinking about the active part of the active learning, right? So group work is the foundation of essentially pretty much all kinds of active learning. And there's a lot of literature in understanding the student outcomes, which is on the right-hand side of the slide, where active learning or various kinds of interactive classroom strategies are correlated with better student outcomes in terms of either cognitive thinking or content learning. It's related to skills development, such as communication and metacognition. It increases students' interest and motivation, and also increases sort of continuation and persistence in a lot of different STEM disciplines. And at the same time, right, so that's sort of the right-hand side is the outcome, and at the same time, the left-hand side is sort of many input variables that might affect how or influence how students are interacting with one another in that small group work that's sort of described in the middle, right? So the input variables could be the demographics, the preparation, their previous experiences with group work, and also what other people are doing in the group, so whether people are on task or not, right? So the idea here is to develop a methodology that allows us to look at what's in the middle, right, where the group work is happening. Traditionally in the literature, a lot of this work is done using very detailed qualitative methods to look at what students are saying, how students are saying these things, and how what are those behaviors and conversations related to either the content, related to processes of science. And so what we wanted to do is to complement this broad and also very deep literature in qualitative methodology, and think about whether we can quantify, right, what's happening in the middle. And so this actually went through a few iterations of data collection, where initially we started out by really just observing the groups and sort of taking down notes. And then that became actually drawing out the sequential order of turns of which student is talking after who, and then really combining those two iterations of data collection into one where we can more systematically track who's talking after who and also what's being said, and also keeping it in a format that allows us to do the more mathematical and computational analysis.
Cool.
And so what we ended up presenting in this paper is a number of case studies that highlight the kinds of things that we could potentially capture using this methodology. So the one shown here is one group. So just to say that all of these groups actually have a peer facilitator there, and that person's always numbered number one. And what we see here is that the students are seated actually in this kind of circle or round table, or I guess square-ish conformation. And what we see here is that each person is represented by a node, or either a square or a circle with a solid or dashed line depending on their demographics outlined at the top. And then when a person speaks after another person, then there's an arrow drawn from one person to the next, right? So if we look at the top, let's say person one speaks first, and then person four speaks, then there is an arrow going from person one to person four, right? And then the thickness of the arrow illustrates how many times that transition happened, right? And so what we see here is a relatively even distribution of turns, right? We call them talk turns because these are sort of turns between talking or transitions between people talking, with the exception that maybe person two is slightly less involved in the talking process, right? And so what the graph theory allows us to do is to quantify this kind of information. Here we have the number of nodes, which are the number of people, which are 4 people. Edges is all the arrows that are involved. And so in this case, all the edges are present. All the possible edges are present. And so then density is 1, right? So density is a normalized number going from 0 to 1 to measure how many of these arrows are present for all the arrows or transitions that could be possible. And then centrality is a measurement of how sort of important an individual is in that graph. And so the more arrows coming in and out of that person will have a higher centrality. In this case, it's 6 because there is an arrow coming in and out of the facilitator, which is person number 1, to each of the 3 other people. But what's interesting is that's individual level characteristics or parameter. And then centralization is the graph level number. Again, goes from 0 to 1. 0 means that not one person is central to the graph, versus 1 there is a very central person, right? So this is going to perhaps make a little bit more sense when we have the second case, which is the other extreme, right? In this case, what's also interesting is, again, the students are actually, or the students and the facilitator are actually seated in this particular format. That's more like a traditional classroom where the facilitator is at the front. And so there are more people here, there are 5 people, but there are actually fewer edges, right? And so correspondingly, we see that the density is lower because there are missing edges in between essentially persons 2 to 5, right? And so again, centrality is a little bit hard to see because it deals with, it actually, the centrality number increases as you have more people. And so the centralization is easier to look at. In this case, what we see is that person 1, right, has a very prominent feature in the graph because every connections or transition sort of happens through this person. And then the last one that I want to share with you is this one that is a little bit bigger group. It had 8 people in it. And what's interesting, and I think this was important for us in developing the methodology, is that we were able to identify subgroups in it that are not immediately obvious, right, if you just look at it. But mathematically, the groups come out actually very interestingly by gender demographics. And so all the men were in a subgroup. except for number 2, which is just sort of off on his own. But essentially, the 4 men on the left-hand side were in a subgroup together, including the peer facilitator, and then person 3, 4, 5 were in another subgroup together. And then additionally, what the graph theory mathematics were able to tell us is by looking at centrality, we were able to identify that person 4 actually has a relatively high centrality, indicating that she was the connection between the 2 subgroups, right? So a lot of times conversations would shift from being, happening in one subgroup to another, and she was often the person that was sort of in between those 2 sets of conversations. And so that's sort of, really thinking about setting up the methodology so that, we can use the quantification, we can use the mathematics to tell us things that perhaps is not immediately obvious by eye, right? So the first 2 cases is pretty obviously different, but then we can get into more sort of nuanced information that allows us to understand the dynamics of the conversation a little bit more. And then I just want to share with you a couple more parameters that we developed. So we're just going to focus on the 2 major, sort of the 2 extreme groups. We actually looked at whether students were posing a question, students or facilitators were posing a question or responding to something, right? And so it's plotted here very small. The graduate student who did this work is young and had really good eyesight. So on the x-axis is question per hour, and on the y-axis is response per hour, and then each dot is a scatter plot of the person, how many questions or responses they had in an hour. And so on the left-hand side, where that graph of everyone seems to be contributing and participating, all the students are in red dots, and then the blue X is the facilitator. And so the facilitator, you can see, is at the edge of that cluster, but it's still sort of relatively close in behavior to everyone else. Whereas if you compare it to the other graph, the facilitator is actually far out on the top left corner compared to the students. We also quantified something that we called normalized turn ratio. So if everyone spoke their fair share number of turns, if everybody spoke the even number of terms or equal number of terms, they would all be normalized to 1, right? And so we see again in that graph where everyone is connected, the normalized talk ratio or turn ratio happens to be pretty close to 1 for everybody except for person 2. And then again on the right-hand side, that other graph, the facilitator spoke about 3 times more, right, of his fair share of turns. And then the last thing is what we defined as episode. In this case, we defined it as the number of turns between 2 questions. So it's not perhaps the best way to define episode, but in a lot of qualitative discourse analysis that people have done on student group work, episodes can be defined in many different ways. But we wanted to set up the graph theory methodology to be able to handle episode. And so we took the simplest definition, which is from question to question. And what we found is that the group on the left actually had much longer episodes where people are having responses either back and forth, or they could just be saying random things, right? We don't know for sure. Whereas on the right-hand side, what we see is a very sort of a lot of episode length of 2, which is a question and then an answer, and then another question and then an answer. Right. So the sort of big take-home message is what can we do with this, right? So if you're observing students in your classroom, even just using the hand-drawn diagrams, you could potentially open up dialogues with them about how everyone is contributing or not. And you can also talk about, whether people can participate and contribute by not speaking in other ways, right? Obviously, the methodology only captures people who are talking, right? And then You can look at, if you have videos or transcripts of students working in groups, you can obviously look at talk turns. Some of the things that we're also adding to the methodology right now, or trying to do that right now, is add in some kind of quality of what's happening to the talk. So either the content, the behavior, various kinds of discourse. Are they making some kind of argument? And then again, the whole point of this is to quantify what's happening in that group work portion of the first slide that I show, and then to be able to study, right, what kind of variables, input variables might influence the group work dynamic, and then how the group work dynamics might correlate to student outcomes. And then obviously, again, we can use this to model talk turns, but we are also looking into modeling the turns of the behaviors and discourse and arguments. And we're also looking into modeling more than one thing at a time. So maybe combining the turns with some kind of behavior.
Great, thank you. So you can go ahead and stop your screen share. So we can just look at your lovely head, but we can go back to that if we need.
Okay.
And again, I'm gonna remind folks that they can use the Q&A feature to pose questions, but I'll start us off with a couple. So I'm curious about how you got interested in this research in the first place. Like what made you decide to start sketching notes about how students were interacting in groups?
Yeah, so it's kind of started out by serendipity. I was actually observing the groups for a completely different purpose. Mm-hmm. And that's some of where those original notes were, just really observing what students are doing, what students are talking about, and thinking about the content and how that might be different from in a lecture course, mm-hmm. or in a more lecture setting of the same course, really. And then I think one day I just started doodling. Right, like literally just drawing lines and sort of mapping out where people were and how they were talking. And then eventually this evolved into a more systematic mathematical strategy in how to really quantify and handle this kind of information.
And were you aware of graph theory, or did you start, like, how did you go about sort of going from your initial observations to really thinking about theory that could apply in there?
Yeah, so I think once I started drawing out those diagrams, they start to look like networks or social networks. And then at the same time, I think, social network mathematics and that kind of theory was coming up in popularity. Mm-hmm. And so we initially called them networks. I think at one point we even called them social networks, but they're really not social, right? And they're really not networks.
So talk about that a little bit. You talk about that in the paper a little bit, maybe elaborate on that a little bit for...
Yeah, so it turns out that social network theory and that branch of mathematics is a subset of mathematics that originated from a field called graph theory. Mm-hmm. And graph theory is about graphs, which in this case are very specifically defined as nodes and connections or transitions between the nodes. So it's not, the same kinds of graphs that we commonly think about. It's a specific mathematical definition of an object that they call graph, right, in this way. And it has different applications. So in physical chemistry, actually, this is used to think about crystal symmetries and things like that. And I guess a popular part of it is to use it to look at social networks, which are, how people are connected or known to each other. And in the social network, a lot of that sort of mathematics is used to see how information could potentially flow from one person to the next or from one community to the next. Mm-hmm. But in this case, so that's sort of the network part, and then the social part.
So looking at flow across those edges and between the nodes rather than looking at the relationship between the edges and the nodes.
Right. So in this case, we sort of actually argue that information is not necessarily flowing between the edges, right? Because when one person speaks, everyone could be listening or not listening,
Sure.
depending on the individual. um, and so what we're really modeling is the order in which people are talking. And so to get away from the, I guess, the implication or connotation of network or social network, the mathematics is actually really similar between graph theory and network or social network theory. But we decided to use the original, sort of more original name where the math came from to sort of distinguish or not have that connotation of information flow across.
Got it. That makes sense. So we have a question from the audience that I'm also curious about. So you started by making these observations yourselves, but did you end up training students to make these observations or training other people to make these observations? And how consistent was it? How did you go about making sure that everyone was really capturing the turns?
So we have collaborations now where graduate students are doing some of the observations. And the turns are actually relatively consistent. They're not easy to miss. I mean, occasionally you might miss one turn, but there's not a lot of interpretation to what's happening or who's talking.
So there's not like a lot of crosstalk in the groups, or?
Yeah, so sometimes there are crosstalks, and we are looking into how to model that, because once it branches, it gets a little bit complicated. But also, we've also done recording, and then it's transcribed.
Right.
Then once we have the transcript, the talk turns are pretty straightforward.
So tell us a little bit about the workload that's involved in that. I mean, so how much work does it take, either if you're doing it live or if you're doing it with transcripts?
I mean, I think the workflow is relatively straightforward. I think at least in this paper, the bulk of the work and the intellectual effort is really in developing the methodology, adapting the math, and then creating a set of R scripts or scripts in R that allows us to automate a lot of this analysis. We're still really tinkering with the scripts to make sure that it works in multiple settings and different kinds of input data. But essentially is taking down the data in the sort of Excel format where we have the sequential order, and then running it through the scripts. So that can be done. There is some work, right? And if there is a transcript, then you have to extract that information. And what we found is that we sometimes use professional transcription services, and depending on who does the transcription or the company, whether they specifically tag, like this is a new line, this is like the timestamp, and you can sort of get like they use like square brackets or something that allows you to maybe automate some of that.
Oh, okay.
Extract that information.
So that you then are just reading the transcript for those notes, whatever the icon is or the information is in the transcript.
Yeah.
To make it even faster. Oh, that's nice. That makes it easier. So I'm gonna, another question from the audience that I think is really lovely, because you are pretty cautious in the paper about not saying like, this is better, or this is worse, not making a lot of value judgments, but it's clear that there are patterns that the cases draw to mind about who's sort of in control of the conversation, who's participating actively in the conversation. And there's a question from the audience who actually, they raised an important question about the fact that there seem to be patterns of what the underrepresented minority student participation is. Although you're, again, dealing with single cases of single groups. And so can you maybe comment on that?
Yeah, so I think I agree with Erin that we were careful in the paper because the goal is really setting up and explaining the methodology, and they are a very small number of cases, although we have picked sort of like the striking ones to show what could be observed. What I think was reassuring to us in those case studies is that in all of those case studies, the distinctive features such as underrepresented students being marginalized, or the kinds of facilitator-led versus student. I don't know what the other extreme. I don't know.
More collaborative versus
more collaborative, right?
Yeah.
Like all of those case studies are consistent with the broader literature has seen sort of on average, right, that underrepresented minority students, especially in a group of perhaps majority students, they tend to be more marginalized. We have looked in the literature and found that the physical spacing matter, right? So that's sort of a chicken and egg problem, right? Because I think the facilitators, those two facilitators, actually set up the rooms that way.
Oh, interesting.
Because they are all sort of movable, like, single desks with chairs attached, like in a sort of classic classroom, like a smaller classroom. And so it's sort of chicken and egg to say, like, well, the facilitator set up the room that way, and then the room sort of influence how they talk about how they participated. But we did find in the literature that the room setup could potentially influence the dynamics of student conversation. And so all the things that we highlighted, we didn't claim that to be true, but it was reassuring in developing the methodology that it's consistent with what other people have seen in the literature.
Right. So maybe you can comment a little bit on, did you intervene at all based on some of the patterns that you observed? Did you intervene at all, or are there ideas that you have for interventions? Did you ever share, for example, the graphs with the facilitators to talk about?
Yeah, so this took a little while to develop, and so we didn't share it with the same facilitators who were leading those groups at the time, but we have incorporated some of this into, for example, we have a pedagogy course for our first time teaching and instructional assistants here. And so we've used some of this information, we've shared some of this information and used it as a discussion activity where they're looking at different participation patterns and how they could, and we talk about the kinds of interventions that they could do, right?
Right. So there's a follow-on question to this that gets at really what the value is of particular configurations. So there's sort of this implicit argument that a more equitable set of turn taking or talk turns is going to be more favorable to the students. And that's certainly consistent with what we know about, social learning theories. But have you actually started to collect any data that looks at outcomes related to patterns that you've observed with this methodology?
Yeah, so we are starting to look at some of that. We're actually starting to look at both sort of talk turns, participation and contribution, as well as more qualitative data of what is the content or the kinds of, are students making an explanation, asking a question, analyzing something. So really looking at the sort of quality and content of the turn as well as the person doing the turn, and then trying to correlate that with outcome data. So part of this is collecting the data is quite a bit of work, and then sort of transcribing and analyzing, especially with the qualitative part. And so we're actually currently collaborating with some chemistry colleagues who do a lot of POGO work in their classrooms, or process-oriented guided inquiry learning is a very group-based active learning strategy. And so
that involves a peer facilitator, or
so
not?
No peer facilitator. Well, it depends actually. So sometimes the instructor is the facilitator, but is facilitating all the groups. And then depending on, the teaching assistants or learning assistant situation, they may have an additional person right there in the group, or maybe one person with a few groups.
So So speaking of the qualitative analysis, I'm curious about when you had many questions. I forget exactly what your sort of start and end point. So you question to question was an episode, and then basically how many talk turns per episode. So where you basically seem to have this pattern of peer facilitator asking a question, getting a response, asking a new question, getting a response, and that seemed to be a pattern for the middle case. Did you look at the nature of the questions that individual was asking versus the nature of the question the less centralized group was asking? Have you had a chance to look at that?
We haven't looked at that one. We actually probably won't have a chance to look at that in this particular data set because they were live observations. We don't have the recording or transcripts.
Right.
What's also interesting is that centralized group. There was actually a lot of self-transitions, which we had removed because the mathematics is more complex if you include self-transition. So in that case,
talk a little bit about what that means.
Yeah. So how that manifested in that particular group is like the facilitator would ask a question, and then nobody answers. So the facilitator answers his own question, and then he asks another question.
I see. So it's like a little loop, a little recursive loop to themselves.
And so we removed it because partly the mathematics is more complex, but also in some ways it's, at least the way that we had collected the data, it's a little bit artificial because we would not see a response to response self-transition. And the only reason why we were seeing that self-transition is because of a shift from question to response. But we could potentially think, so, parsing out whether a response to response self-transition, like, if I'm talking about one thing and then suddenly I decided to talk about something else, that could be a self-transition, right, within the response. But in setting up the methodology, that was a lot more qualitative work that we didn't have the data to do and probably wasn't the right time to do that. And so we got rid of those self-transitions.
Yeah, that makes sense. I mean, you have to sort of decide what's a manageable chunk to work on as a researcher, right? And then say, all right, we're not going to let perfect be the enemy of good enough, and we're going to get this chunk of work done before we move on to what its next potential is. So speaking of, another good question from the audience, and I'd encourage you to keep those questions coming in, please. And this relates to looking at group dynamics over time. So did you have a chance to collect the same data from the same groups over time and look to see how consistent that pattern was?
Yeah, so that's another one of those questions that we're exploring. And I can share some of the some of the preliminary observations that our collaborators have seen. So Sally Honeycutt, who's a chemist at Virginia Commonwealth University, we've been looking at data where it's not quite like how the group dynamics change over time, but it's within like the same lecture or class session. It would be the same problem, but before or after a full class clicker question.
Okay. So, I see like how the particular instruction that's happening is influencing how the group interacts. Is that right?
Yeah.
Got it.
And then Renee Cole, who's also a chemist, right, at Iowa State, she shared some data where I think the groups change over time, not necessarily because of overtime, but like one person didn't come to class that day, and that person, might be typically the person who asks a lot of questions or sort of either clarifying question or sort of intellectually, I guess, pushing the boundaries kind of questions. And so when that person wasn't present, then the dynamics seem to have changed. But we do want to look at how groups sort of, right, you can imagine maybe, especially in the first week or two, they haven't if they are consistent group, well, actually both, right? If they're consistent groups through the semester, maybe, right, they get whatever better means, but they get better at working together. Or if the groups get switched every week, one might also argue that they get better, right, at working with new people. So that's obvious. Yeah, that's definitely a hypothesis that we want to look at is what are the influences of like both one person being in a group, but also longitudinally what happens as people work together.
Yeah, that's really lovely. You could imagine that in a class you could track, centralization on average for all the groups across the class, and see whether, that switching or non-switching actually leads to more or less centralization. So that sort of brings me to a point that I want to draw more attention to how you communicated about this work in your paper. What I really liked about one of the things I really liked about this paper is that you picked 3 cases that illustrate your points. And I don't know, can you talk a little bit about how many different cases you had to choose from and then how you chose those cases?
Yeah, so we had a total of about 15 groups or 15 observations. Mm-hmm. They were unique groups, so they weren't, there were no repeat observations of the same group.
Got it. So then none of the participants in any group were also in another group?
No, yeah.
Right, okay.
They were not, sorry, yes. Right. So the question is how did we pick those 3? Mm-hmm. I think in the paper we talked a little bit about that. So we had sort of mapped out there were essentially 2 extremes, right? And so we picked really the extreme of the 2 extremes.
So the extremes in terms of centralization.
Centralization.
Very decentralized and very decentralized.
Yeah. Mm-hmm. And so we found that most groups fall into the sort of collaborative decentralized or the facilitator-led centralized. Mm-hmm. And so we picked the very extreme of those 2 extremes as 2 cases. Mm-hmm. And then we really picked the third one, not necessarily because it was intermediate, but really because of the subgroups and how it was highlighting something different. And that's also because we were hitting some of the mathematical boundaries. Like that group turned out to be bigger, and it's just mathematically it's harder to identify subgroups when the groups are small. Right? And so there may have been subgroups in the other ones, but it's just not potentially showing up, right, using the math.
Was that the only group where you saw the subgroups?
That's, I think, there were 2 or 3 groups that had subgroups, mm-hmm. But they were all in the sort of 6 to 8 people range. So they were all
right. So that's a really lovely argument in favor of keeping group size for 3 or 4, right? Because you don't get that fractionation of the group into 2 subgroups, as you would with a larger group.
Yeah.
Yeah, absolutely. So what I love about that sort of choosing, that logic behind those choices is that sometimes folks struggle with, what really is a case about. And your case really nicely illustrated, your cases really nicely illustrated that you wanted to make particular points about how the methodology could operate. And you chose those cases really strategically to represent the range of ways this methodology could be used, as opposed to just 3 instances. So it's a little bit different way of thinking about how do we present cases in the education research literature. It has to be something unique that the larger audience can learn from.
Yeah. So Jennifer Case, she does not necessarily do case studies, but she's a qualitative engineering education researcher in South Africa. She has this lovely review of qualitative methodologies from about 10 years ago now, where they talked about case studies, and I often refer back to that review and the subsequent book chapter that she has written, is that case studies are really useful either as like a single instance of a very complex problematic situation where you can now take the case and look at it from many different ways, or they are useful in sort of representing a wide spectrum or a full spectrum of what's happening in the phenomenon. And they are sort of like important endpoints and middle points of that allows you to see the variation without having to wade through all the data in some sense. Right?
Nice, thank you. So are there, imagine you could go back in time. Are there things that you would have done differently? Or are there things that you're doing differently now that you've developed the methodology moving forward that other people could learn from?
Yeah, I mean, I think in retrospect, it would have been nice to have the recording and the transcripts.
Yeah.
Not only because then the turns are more definitive, but it would have also allowed us to get back into the data to address or try to explore some of the questions that the audience has come up with right here. And another thing is I think developing the methodology, we actually examined or explored a number of different software platforms. So we actually started out with a Node XL, which is a Excel add-on that does a lot of this kind of network and graph theory mathematics. It's pretty fun and convenient to use. And then, it has other limitations. And then we moved to some of the social network software platforms like Gephi and a few other ones. And then I think in this case, the students, Albert and Andrew and Josh, who were involved in this, are very computationally inclined, and so they wanted to write their own scripts in the software package R, which allowed us to do a lot of customizable things. We're not starting from scratch because there are existing scripts in R that other people have created that deal with social network. And so we are pulling, a lot of those existing scripts and incorporating them into ours. But that's also allowed us, so it's a trade-off, So Aaron, you were laughing, which is true, It's a lot more work to sort of set that up on our own, but on the other side, it's doing sort of exactly what we want it to do. So that's been some of the struggle as well.
Yeah, I forget, did you actually include any of the scripts in your supplemental materials on the paper? Or can people contact you to get?
Yeah, people can definitely contact me. So a lot of that work that's presented in the paper were not run in the R scripts.
Got it.
I mean, some of it was.
You developed the scripts after the fact.
It was sort of like concurrent.
Yeah.
And so we're trying to clean up the scripts right now so that we can, have it in a shareable format.
Great.
In a shareable format where people don't need to contact me, right? But
yeah,
right now I'm happy to share sort of as people are writing me. So
great. So from a sort of more practical perspective, both research-wise and instructor-wise, I would obviously predict that your first case would be more equitable or inclusive than your cases, 2 and 3. Are you actually going about testing those hypotheses, like comparing? And if so, how do you actually get at that? Besides the fact that you have pretty similar levels of turns or pretty decentralized dynamics. Like, how would you know?
Yeah, I think we can only measure what we can measure, right? And then the conclusions that we can draw need to be interpreted, within the limitations of those measurements, right? And so I think here, the limitations are really that talking is really a proxy for participation and contribution. Even on-topic talk, right? It could be a very quick on-topic talk, like, yes, I agree, to a much more in-depth sort of conceptual or intellectual exploration or argument of something. It could be a off-task talk, right? So we have these transcripts and recording where somebody just said, I'm really hungry, I'm gonna go get a scone and come back, right? But that counts as a turn officially, right? And so we can, make some decisions of like, we can remove them or something, right? But I think right, so I think the assumption is that more equitable turns are more equitable. But I think we have to interpret that within the limitations of what we're measuring or capturing.
So would you expect, for example, there to be less of a range or a smaller standard deviation of performance in a group that's less centralized?
I think that's possible. That's certainly our hypothesis and based on what exists in the literature. You can also imagine, right? Some of that could do with the classroom culture and the active, the classroom culture that's been set up in the course, and also the culture both in the classroom, maybe in the broader, right, institutional context of how students view this kind of interactive activities in class, right? Like I can imagine a scenario where everyone's talking and participating evenly, because you have to write down something and turn it in. And that counts for something, versus another or the opposite classroom culture where it's really about the discussion and the process. And, so I don't know whether, my guess is the second scenario where people are focused on the learning and the process and the discussion, probably a smaller standard deviation of outcomes and more equitable. Whereas the first one, I don't know if that would be the case, or it might actually amplify the differences. And I think one could make a theoretical argument either way for that case where people are like participating but not engaging. I don't know the right phrase for it, but and so then in some case, like this particular iteration of the methodology is really capturing participation, right? Which, I actually explain this in my syllabus and in my courses. Like I talk about attendance versus participation versus contribution.
Yeah. Oh, interesting. So what do you say about that?
So I say, because I think some students are used to some experience where clicker questions are used for attendance.
Yeah.
You just have to show up. So I explain attendance is you're physically there, right? And then participation is you have done the thing you're supposed to do, right? But then contributing is really about like figuring things out, both for yourselves and together, right, with your group. With the goal of like actually learning something and
yeah.
Right? And so I think I actually hadn't thought about this until this moment when we're talking about it, but I think that the methodology here is really capturing the participation, right? Not quite the contribution.
Well, and that's where I think your qualitative work is important, right? Because you're going to be able to get the contribution when you look at it qualitatively. I mean, I assume you could think more carefully about what counts as a turn, or, the nature of the turn to think about contribution versus participation. But if you're not participating, that's not, there's nothing to count there.
Yeah, and then actually that's an interesting question, right? Can you contribute by not talking, right? Because I think there may be other ways to participate and contribute that doesn't involve talking.
Yeah.
Um,
But I was wondering if you had, when you asked that question of if there's ways to contribute when you're not talking, if it's the people who tend to talk can contribute by creating space by not talking. That's an interesting question. Well, I'll tell you what, we're almost out of time, so I just want to ask you a couple more questions, and then we're going to throw it back to the audience. If someone were going to use this methodology going forward, either to look at their instruction or in their research on, for example, group dynamics, is there any advice you would give that you haven't already given? You mentioned the idea of making videos so that you can actually use transcripts.
Yeah, I think videos and transcripts, or I guess it doesn't have to be video, it could be audio recording and transcripts. But I think transcripts is probably the most sort of consistent and systematic way to do this. And then I think another important question is really, what is the question, right? Like, what is the research question or pedagogical question that you're thinking about? And whether, whether the graph theory methodology is needed to answer that question, right? So that actually came up in my student Albert's thesis defense, right? One of the committee members actually asked, so what is this telling us that, like, normal or conventional statistics without the graph theory mathematics is not going to tell us, right? And then I think, because I think it's important to focus on the questions and hypotheses as to then drive the, what methodology is needed, versus to say, oh, we have this cool thing.
I have a hammer.
Let's use it to.
Let's make it a nail.
Right.
Yeah.
To do things. And I think that maybe that would be like another piece of.
Yeah, it's true. When you have a hammer, it's easy to see things as a nail. Yeah. So thinking about that strategically is a really good point. Well, what I'm going to do now is ask Stanley to pull up the penultimate slide. And this is a little formative assessment for us. And that is to ask you as the audience to type in the chat box, so not in the Q&A, but in the chat box, one interesting thing you learned during today's session. So take just a minute. One interesting thing, type in the chat box that you learned. Keep those comments coming. And then I'm going to ask Stanley to turn to the last slide. And I'm going to thank him very much for his time. I really appreciate your sharing your expertise with us. And being willing to tell us a little bit of the behind the scenes. Sometimes that's a scary thing as an author, because you actually put out the laundry that went into this really lovely polished product. So thank you for being willing to share your experiences. And for folks who are online, I would ask you to use the chat box for one additional thing, and that is for you to suggest other LSE papers, authors, or topics that you would like to see featured in Online with LSE. And please mark your calendars for Friday, September 20th, when we'll have our next Online with LSE session with Erica Offerdahl. And at that point, Stanley's actually going to be the facilitator, and he will talk with Erica about her work. So please take, again, a few minutes before you sign off to make those suggestions and continue to comment on what you learned. And thanks again, Stanley. I really appreciate your time.
Thank you so much for having me here today, and look forward to being back here in a different role in a month. So,
Excellent. Thanks. And folks, have a good weekend.